So today we're going to talk about organic molecules and carbohydrates, okay? So we're going to talk about the difference between organic and inorganic molecules and explain how organic macromolecules are put together and broken apart. And then discuss the overall structure and function of carbohydrates. You guys are going to be filling out a biochemistry chart next time. Oops. All right. There we go. Okay. So the chemistry of carbon. So most living things are made of carbon, hydrogen, oxygen, and nitrogen. We call that CHON, C-H-O-N. And these are all elements that make up most of life. Most of life is mainly made of carbon, and the reason why is because carbon actually has 4 available spots to bond, and because of that it can string together carbon chains to make up a lot of big macromolecules. Macro meaning large, micro meaning small, so macromolecules. What is an organic molecule? So organic simply means that it contains carbon and hydrogen bonds, and it's found in living things. So another way to think about this is having a hydrocarbon chain. So that's carbon and hydrogen, not necessarily water, even though water is important for life. Hydrocarbons only contain carbon and hydrogen. And an inorganic molecule then are the molecules that do not contain that carbon-hydrogen bond. So basically everything else. So some important prefixes and suffixes. Mono means one, di means two, poly means many, macro means large. Excuse me. Suffixes. So these are the things at the ends of the words. Mer is a unit, and saccharide means sugar. Okay. Another way to think of a sugar is also if it's some sort of carbohydrate, and we'll talk about that later as well. All right, so organic molecules are really large. They have carbon-hydrogen bonds, and there are 4 categories that we're going to talk about. We're going to talk about carbohydrates, lipids, proteins, and nucleic acids. These are the main components of the chemistry that makes up life. So when you take chemistry next year, you'll talk about other sorts of molecules, but in biology, we're only going to focus on the molecules of life. So monomers and polymers. So mono, remember, means one. So these are small building blocks. Okay, you could think about them like the like blocks. Okay, so a monomer then would be one block, and if you were to stack those blocks together, you would make a much larger tower or a larger block, and that would be an example of a polymer. So poly means many. So polymers are long chains of monomers simply joined together. And most organic molecules are polymers made of several smaller monomers linked together. So life likes very, very long polymer chains. All right, when we want to break polymers, what we're going to do is we're going to add water. So if you remember, properties of water from the video that we saw last week is that water likes to dissolve things. So when we add water, it's going to help break down polymers. Okay? When we remove water, we're going to join monomers together. So if we're adding water, we call that reaction hydrolysis. So hydro meaning water. We're adding the water. We're going to break things down because, again, water likes to dissolve things. All right. When we want to join monomers together, we're going to take the water away. And another way of saying that is dehydrating it. And so that is a dehydration reaction. Okay. So that's going to link our monomers together. All right, so this just talks about hydrolysis. So when we want to add the water, it's going to break things apart, and it's the opposite of dehydration, okay? So in the picture, you see sucrose, which is 2 ring sugars joined together. We're going to add water. So sucrose is just a simple sugar. We're going to add water. It's going to break it apart into 1 glucose and 1 fructose. Okay, it's going to break it down. And in your mouth, actually, what is most of the stuff? What's the stuff in your mouth called? Saliva. And what is saliva mostly made of? Water. Well, why? Because water is going to dissolve it. So actually, before you even eat any food, your mouth is already breaking it down with the saliva. Okay, so you're going to be able to break some of those carbohydrates down already before it even enters your stomach. All right, so carbohydrates. Carbohydrates are organic molecules made up of sugar molecules. They only contain carbon, hydrogen, and oxygen, and they can be arranged in very different ways. So if you look at the ring structures, you'll see some common ways that we can arrange carbohydrates. So carbo meaning carbon, hydra meaning hydrogen, and then anytime you see an ATE at the end of a molecule, that means there's some sort of oxygen at the end. So that's a carbohydrate. They can be very simple, like glucose is a very simple sugar, or they can be very complex, starch and cellulose. Okay, so starch and cellulose. Cellulose is in plants. It provides the structure for cell walls, and starch is kind of what the plants store. And most have a ring shape. Okay, so we call that hexagon, pentagon shape, a ring shape. Monosaccharides are simply just one sugar. Mono meaning one, saccharide meaning sugar. So examples are fructose, galactose, and then some glucose. Monosaccharides are important because we use these for quick energy. So if you eat candy, or if you eat pure sugar, you're eating monosaccharides, and those are okay as long as you're going to use that energy right away. When your body doesn't burn that energy as energy, then your body's going to try and store it as fat. So really, monosaccharides only become a problem if you're eating them and then not being active afterwards. Okay, so these they break down really quick. Those are our quick energy and things that you would want to eat right before a game. I know that I have the little the gel packs or the gel chomps, that when I do my running, and I always eat those right before my race, so then I'll have some quick energy because I'm going to be running and using the energy right away. All right, disaccharides, just as it sounds, di meaning two, saccharide meaning sugar. Disaccharides are simply just two sugars joined together. So it's a little more complicated than a monosaccharide, but still relatively a simple sugar. These also break down relatively quickly in the body. Okay, examples: sucrose, lactose, and maltose. So lactose being the sugar in milk, sucrose being the sugar in table sugar. And again, these can also be used right away. So sometimes what athletes like to do is they like to have a glass of milk right before a game or right after to kind of replenish the stores of energy and stuff like that. So that's where that comes from there. And anything that ends in an ose, O-S-E, is our second suffix for our sugars. Okay, so anything that ends in O-S-E is also a sugar in addition to saccharide. All right, polysaccharides. A little more difficult to understand. Poly means many, and if you look at the picture, there are many, many, many repeating units of sugars joined together. Okay, so these are more complicated, and because they're more complicated, they break down in the body more slowly. So these are our starches. So if you're going to have bread or a potato or something, those are considered starch, and that is going to take a little bit longer. So usually they recommend, if you have a big game or a big race, that you want to increase your polysaccharides the night before. So you've heard maybe of having a pasta feed before a swim meet or a game. That's because the polysaccharides are going to that night start breaking down, and then it actually gets stored into your liver as glycogen, as temporary storage, and then you can use that energy the next day. Okay. They also recommend that you eat more of a polysaccharide for breakfast because it'll stick with you longer. So that's going to be your toast, your wheat toast, or your oatmeal, things of that nature. Those are polysaccharides. Okay, what else? And then I talked already about the cellulose, right? So cellulose it's the stuff that makes up cell walls. And celery has really dense cellulose structure. So you can think of celery when you think of cellulose. All right, so that's all we're going to talk about today. We talked a little bit about our molecules of life and how all carbohydrates are made of carbon, hydrogen, and oxygen, and they can be mono, di, or polysaccharides and how the body uses them. Next time we'll talk about lipids, proteins, and enzymes. All right, see you next time.